Okay, so parabolic shape of a Humber River pedestrian bridge can be modeled with this. Okay, so where x is the horizontal distance in meters from the end and h is the height. Okay, so let me factor out. Now 144 is 12 times by 12, which is, this is 6 times by 2. So it's 6 times by 24, right? Okay. So what you want to do is factor this bigger value out. So when you factor that out from this term, it's just gone. We also want to factor out x. Then you're left with an x minus, okay, there's only a factor of 6 at the bottom here, so we actually have to multiply the 5 by 24, okay. So this is 120, right? 120. So just a rough graph. This has x-intercept as 0 and at 120. Okay. And let's plug in 60 for the vertex. Right, so that gives you minus 60 if you plug it in here. So this is, 6 times by 2, 6 times by 2. So it's going to be 1 over 4, 10 times by minus 10. Reduce, you get 50 over 2, so it's 25 meters vertically up. And this happens at 60. So the shape of the parabola looks like that. Okay, it's the height, this is the x. Okay, so this is literally the shape of the bridge. Okay, so what is the height of the bridge? At 12 meters from one end. Okay, so that's just h at, this is the answer for part B, h at, when you replace x with 12. Okay, so all right, I'm just gonna punch that in the calculator. That you can reduce that, and that gives you 10 minus 108. That gives you a nice value of 9 meters. Okay, so when we're at 12, we're at 9. 12, 9. Okay, so for part C, how wide is the bridge at its base? We determine that by the two roots, 0 and 120, so it's 120 meters. D, what is the maximum height? That happens at 60, which I already found to be 25 meters. Identify the axis of symmetry. That's when x is equal to 60, right? It's symmetrical about this vertical line right here.